Hello, Christian here with another progress report update for the pfSense WireGuard package. There's a lot to talk about in this video, but let's go ahead and start off with the big news. The package is now being built by Netgate and is available in the 2.6 package repository. So if you are using the development snapshots, go ahead and check it out. You can find it as you normally would under System, Package Manager, and you can find it under Available Packages, and it's under WireGuard. I'm actually doing this demo on 2.5.1, so you're not going to see it there. So I honestly don't know if we'll ever expect to see it on 2.5.1. I've seen some communications from some Netgate engineers on Reddit suggesting that the 2.6 Community Edition release might be coming out sooner rather than later. I know there's still some bugs with 2.6, but I know that 2.6 is actually fixing a lot of issues with multi-WAN and NAT that are plaguing users on 2.5.1. So I'm not really sure exactly what is the story there. But as always, if you're interested in running the package on 2.5.1, you can follow the link in the description to my GitHub page and download the pre-built packages. So let's go ahead and talk about some of the changes to the package. So this is going to be a pretty significant update. From the last version, a lot has changed. Probably the biggest change is we are no longer using WireGuard Quick, WG Quick, under the hood to perform all of the backend stuff that we need to do in order to build tunnel interfaces and tear them down and to do other administrative tasks like add or remove addresses and whatnot. WG Quick was really beneficial for the project in order to get a proof of concept working very quickly. But because of how integrated the pfSense platform is, there are better tools available to us to actually manage the lifecycle of the WireGuard interfaces, the tunnels, that we just couldn't achieve that level of granularity with WG Quick. WG Quick is very aggressive, kind of out of the box when it comes to life cycling of the tunnel interfaces. So even very simple administrative tasks like adding or removing addresses or adding or removing peers, using WG Quick alone, you would actually have to completely tear down the interface and then rebuild the interface with the current configuration. For those of you that have any experience with networking, understand that changing an address shouldn't require tearing down the interface. You can add and remove addresses without downing the interface. And in WireGuard, in the world of WireGuard, you can add and remove peers without tearing down the interface as well. So I have been working on a complete backend rewrite, and we are no longer using WG Quick, which means we're no longer dependent on carrying along Bash as a dependency. And we're also using the light flavor of the WireGuard tools. So that's pretty cool. So this actually brings a lot of benefits to the stability and also to the user experience. With WG Quick, every single modification, change to a tunnel or a peer actually required interacting with WireGuard Quick, which meant you were locked. So the system was locked, waiting for WireGuard Quick to do its work in order to tear down the interface, build it, or do whatever it was doing administratively. Now, because we're no longer using that, and we're instead using lower level tools like the WG command and ifconfig and route to handle all the things that we actually need, and we're not using WG Quick to be middleware between the package and the WireGuard subsystems. Things are just a lot faster. So let me talk about some of the engineering changes that have been made. First of all, any tunnel that you have created, whether it is enabled or not, you're going to have a corresponding interface created. So in this case, you can see that I have ton WG0 and ton WG1. If I open up a console and I actually look at the output of ifconfig, you're going to see that there's ton WG0 and ton WG1. But let me go ahead and create a new tunnel. So let me go over here and add tunnel, and we'll just give this a private key. We'll call this test, and we won't give it an address. We'll put save. Now this tunnel is enabled, but let me go ahead and disable that. And what you're going to see is if we go back to the console, we're actually going to see ton WG2. It's there even though it is disabled. But notice that this interface is administratively down. It's not up. So notice that ton WG0 and WG1, they're up and running, okay? But WG2 is not. So if I come back here to the interface and I toggle that on and go back to the console, let me just clear that and run that again, you'll see that ton WG2 is now up and running. So this is a big change because now we can toggle tunnels on and off, and doing so, we're not actually tearing down the interface. We're just toggling the interface administratively up or administratively down. This is a lot less aggressive than the way that we were doing it before, which was using WireGuard quick to down and then using WireGuard quick to up the interface, so that we were ensuring that our desired state was matched with the actual running state of the tunnels and the interfaces and the assignments and whatnot. So this is a really, really big change, and it means that things are a lot snappier. Toggling the interface on and off, it's really, really quick. And again, we can come back here and we see that the interface is running. Let's actually go and add an address to the ton WG2 interface. I'm just going to click on the edit icon here. Notice that I've made some UI changes. Kind of going off on the theme of how interface icons. I was trying to make it very obvious on what these shortcuts do. So you can click on the interface assignment shortcut to take you right to the interface assignments page, and the icon there corresponds to that. And I also added one for the firewall rules, which I thought looked pretty good. So let me go ahead and add an address here. We'll just say 10.10.25.1/24, and notice that we now have a description field. One of the things that I have been noticing after studying the pfSense code base is some of the design choices that the Netgate engineers have been making along the way. So there are aspects of the pfSense code base that are obviously older than other aspects. And some of that is actually influencing some decisions that I've been making internally with the package. And one of the things that I've noticed is that instead of storing things like addresses and whatnot as just a single entry in the config separated by commas, it actually makes more sense to just use XML, which is a hierarchical structure. You can have arrays kind of built into the structure, using tags to very explicitly store bits of data and not relying on first parsing the config and then parsing some intermediate structure like comma separated values or whatnot actually within that tag. So instead, what we're doing is we're actually storing each individual row, and we're storing the IP address, we're storing the mass, and we're now storing a description, because this change of breaking that out has meant that we can actually add more capability easier. So we now have a description. So I can come in here and say, remote, gateway, if this was maybe like a Road Warrior setup, and the 10.10.25.1 address was what I was pointing all of my Road Warrior clients at as their default gateway. So I can go ahead and save this, and you'll notice that this is very quick. Hit save, and boom, it's done. And what this is actually doing on the back end is when you add and remove addresses, it takes the desired state, which is the state that you actually configure in the user interface, and it compares that state with the current state, which is the state that the interface is actually in at that given point in time. And it does some array diffing to figure out what addresses need to be added and what addresses need to be removed. And it will add the addresses that it needs to add, and it will remove the addresses that it needs to remove. And it never actually downs the interface. So if we come back into here and just run ifconfig again, you'll see the 10.10.25.1/24 address is now bound to ton WG2. I can come back here and I can add another address. Let's add another address. We'll say 10.10.25.100/24. And we'll just call this test2 for no other reason, but just to demonstrate. It's saved. Again, it's really quick. And we have the address. And if we go back to the console and run ifconfig again, we see that we have that address. We can do the same thing for IPv6. So let's go ahead and just add an IPv6 address. We'll do fd9a1 and /64, and we'll call this test IPv6. And hit save. And again, really quick, really fast. And if we go back to the console, boom, there's our IPv6 address. And likewise, I can delete these just as quickly. Delete, hit save. And again, we go back to the console and go right back to where we started. So again, we're no longer relying on tearing down the interface and rebuilding it just to just to achieve that state synchronization, or that, I don't want to use the term state because that might confuse people with actual PF states, but the relationship between the desired state, which is what you, the user, configure in the user interface, and the current state of the system, which is the actual state that the underlying components are actually in at any given time. So what we're actually doing is we're being very intentional in not tearing down the interface unless the interface is legitimately needs to be torn down. In this case, the only thing that would tear down the interface is if you actually delete it or the system is shutting off, which obviously tears down all interfaces. So if I come in here to TONWG2 and I click delete and click OK, this is the time where the interface is actually removed from the system. It's not removed if I toggle it. It's not removed if I, if I toggle it. It's only removed if I actually remove it. So I click Add Tunnel, and I'll just add a tunnel, but this time I'll actually leave it as disabled. We'll give it a private key, and we'll hit Save. And again, this tunnel is disabled. If I go back to the console, you're going to see that it is not up. It is administratively down, and it would not be passing traffic. So that is a really, really big change. It means that the UI is a lot snappier because we're not locked. We're not waiting for WG Quick to do its job. We can now just do it for ourselves, and it's a lot faster. So I was really kind of proud of that. It works really well. And again, we're just comparing the desired state with the current state and updating things accordingly. So yeah, that's a big change. It works really well, and I'm really pleased with how that has turned out. Again, I've added some kind of some quality improvements here. Again, I'm kind of open to suggestions. But in this case, you see that I have two interfaces. I have a WG0 and I have WG1. WG1 is an assigned interface, and it's assigned to the Mullvad interface, which I can come up here and click on that, and you can see that I have a Mullvad set up. I'll talk about that in a second because that's actually a question that's come up several times in the forums and on Reddit and whatnot. Is using Mullvad. I actually signed up for a subscription yesterday to do some testing, but I had no idea that Mullvad was so was such a There are people that are using WireGuard in pfSense, and this is the use case. So I want to make sure to get that right. So I'll talk about that in just a second. Go back to the WireGuard package, the tunnels list. Let's look at a few other changes. If we go to peers, not much has changed here. Oh, actually, something has changed pretty dramatically. So if you remember back on the last video, when we added a peer, I had these two checkboxes to allow all IPv4 and all IPv6 addresses. We have removed that. Manoj did some investigation into why these repeatable mask input boxes had that little quirk where only the first one would be scoped 128 all the way down to 0, and subsequent entries would only go from 128 to 1. There was actually a bug in the JavaScript that we actually pushed back upstream, and it has already been merged into 2.6. Until that time, we actually have a little shim in the code that actually includes that fix. So if those of you that want to run this on 2.5.1, not a problem. You're going to get the fix anyway. But until that fix is actually, we're going to keep that in there kind of for the foreseeable future. The fix is in mainline, but we also have the problem fixed in the package that we're using to just override that. So regardless if you're on 2.5.1, which doesn't have the fix, or you're on 2.6, which does, it's going to work. So we no longer have this, these checkboxes. If you want to allow all IPv4 or allow all IPv6, you can just type in 0.0.0.0/0 and doobly-doo/0 for IPv6 and save. Oops, I actually need to type in a public key. Go ahead and do that and hit save. And again, let's see, did that not work? Try it again. 0.0.0.0/0. Oops, I might have a little bug here. Of course I would on a demo. Let's see, 0. Maybe let me just type in a description here, make sure that's working. Yeah, okay, so I'm not sure what happened there. I need to check on that because I'm pretty sure if I'm, yeah, okay, so it's coming. That might have been a bug. Let me try that again, just for the, I'm not trying to hide anything. Let's just do this unedited and see what happens here. Let's just create an unassigned tunnel. We'll give it a random public key. Let's go ahead and 0.0.0.0/0 IPv4, and then we'll do another one. We'll say doobly-doo/0 for IPv6. And let's hit save. Okay, that worked. So let me do another one. Let me leave the descriptions off. I wonder if it's not saving because the descriptions are blank. I'm not really sure. Let's try this again. And let's do doobly-doo 0. Save. Oh, that worked. I don't know. Maybe I'm going crazy. Anyway, okay, so cool. That's working. So let me just go ahead and delete those peers. Not a problem. Boom, boom, boom. Okay, so yeah, that is a change there. You no longer have to check that box if you want to allow all IPv4 or all IPv6. It works, and we handled that. There is still one limitation that we're working on, and that is route creation. So currently, if I were to come in here and add a peer, and I were to say I want to allow, 192.168.10.0/24, if I wanted to allow this entire subnet, this is not going to work because I haven't actually created that. If I hit save, this is not yet creating the route automatically. If you wanted the route, you're going to have to go and add a static route or use some kind of dynamic routing protocol. Currently, the allowed IPs, these rows are only allowing those addresses to actually pass through the tunnel. It's not doing any kind of route creation. That's something that I'm working on, and it will be coming soon. We're never going to create a default route for 0.0.0.0/0 and doobly-doo/0 for IPv6. We're never going to touch that. That is going to rely on the system. That is going to be always configured through the system routing tab. We're never going to touch the default route on the system. But we can create routes for non-default routes, and I'm still kind of working out how that might work. Some people have suggested to just create them by default. Yeah, I'm still thinking about that. Most likely what there will be is a checkbox. There's lots of different use cases that I want to consider. We might add a checkbox next to each row that just allows you to uncheck default route configuration. I don't know. I'm still working on that. If you have suggestions on how you might like to see that handled kind of in a real-world application, leave a comment in the description or open up an issue on GitHub or post in the forums, the Netgate forums, or post on Reddit. I'm reading all of those things. Yeah, so that is a big change. So no more checkboxes. Yay. Let's see, status. So the status page. This is something that has gotten a lot of work. We have been kind of toying with some ideas in Discord with some different changes. One of the changes that you're going to see that's not yet in this interface is we're going to add a panel for routes. So I know that it's useful, like in the OpenVPN world, to see the routing table as it relates to OpenVPN. I'm going to do the same thing for the WireGuard. So Manoj has actually written a route table view that will pull in routes that are specific to WireGuard tunnels, and we can see those here. I'm going to put that code was actually merged in, and then during my rewrite, I actually removed that just because I was, I had a lot of things that I was juggling in my head, and I wanted to only focus on one thing at a time before I actually got that back into, the builds, the branch that we're actually building from. So that's going to come back, but this is the current status page, and what you'll see is we now have rows for each individual tunnel interface. And these icons are dynamic. So currently, ton WG0 and ton WG1, they're up. They're passing traffic. We can see that we have transmit and receive bits shown in a friendly way. So in this case, the Mullvad tunnel, I've received 29 meg and sent 40. Just to kind of show you that, my phone is actually using that. So what's going on here is that this particular dev box is actually in Vultr. So my phone is connected via remote access, and then I'm connected to Mullvad. So this is kind of like a two-hop thing going on. So my phone connects to this box, which then routes over to Mullvad. So if I click and actually enable this VPN on my phone, and let me refresh this. Let me go ahead and show the peers here. You can see that my cell phone has had a handshake very recently. And what I can do is I can just run a speed test. And you can see these stats change. So if I click go on a speed test here, and let's just run that, hit status, and you can see that we're transmitting and receiving. So notice that where we're receiving, we're sending, and where we're sending, we're receiving. So obviously, we have traffic passing into into ton WG0, and then we're routing that back out to ton WG1, and it works. So that brings me to the last point that I wanted to discuss, and that was Mullvad. I feel like that needs to actually be discussed by name, although this probably will apply to other VPN providers. Oh, by the way, one more thing. This little show peers button, I'm not married to it, but it currently exposes all of the tunnels, but if you just do a single click, actually, no, I forgot to put that back in. I do have some code that if you just click on one row, it'll just expose that one row. So something to look for. So Mullvad. There were some questions on the forums and Reddit about this, and I honestly, up until late last night, I had no experience with Mullvad. The Mullvad configurations that they give you, if you open those configurations up, and I'll go ahead and open up one here. Let me open up one. Let me open up one and I'll obfuscate the keys just so we're clear on what's going on. Okay, so let me go ahead and redact some stuff here. And yep, I'll just hide all the keys. So this is a Mullvad config file that you would actually get when you download. When you actually sign up for Mullvad and you download the zip file or whatever. So the way that you would actually kind of translate this into a config that will work with the package is you need to assign an address. You actually need to assign the tunnel to a pfSense interface. So in this case, ton WG1 is assigned to this Mullvad interface. So let's start there. So I added a tunnel. And what I did is I took the private key from the configuration file that I downloaded from Mullvad, and I put that private key into the private key, the interface key on that tunnel. So if I go back to tunnel here and I edit the Mullvad tunnel, again, I'm blurring this, so that's a feature in use right there. This private key is the private key that came from the Mullvad configuration. Okay, and the listen port can be whatever you want, because that's the port that Mullvad's going to talk back to you on, which is going to be, you're going to send that to them when you try to handshake with them. And that's pretty much it. That's the only thing you need to do in respect to the tunnel through WireGuard. Then what you do is you come into interfaces and assignments. And you're going to assign that as an interface. And then you're going to come in and you're going to give it a static IPv4, and if you want a static IPv6. And in this case, what I did is I took the /32 address for IPv4 and the /128 address. These are both host addresses for IPv4 and IPv6. I threw those into here, and then I created a gateway for each one. I call it Mullvad Gateway and Mullvad Gateway 6. And here's where it's a bit non-intuitive. Because this is a /32 and a /128, the actual gateway address is also the tunnel address. So it's not the far end. That's just the way that you do it. So in this case, you can see the upstream gateway is the same as the IPv4 address, and the upstream gateway for v6 is also the v6 address. And then you click Save and Apply. And from there, really all you have to do is add the peer and do some NAT and firewall stuff for policy-based routing, and you're done. So if we go back to WireGuard and peers, here is the Mullvad peer. I just named this Mullvad-US4, which was the name of the config that I happen to use. They give you an endpoint and a port. I got that from here. And then you want to allow all IPv4 and all IPv6. And it works. You can set a keep alive if you're behind NAT. I had mine for 30 seconds. And that works. And click Save. Oops. Oh, so I also added some other checks too. It's yelling at me because this key is already assigned. I need to add a key. I need to add a check that allows you to resave, but it's saying that this key is already assigned to appear on this tunnel. I can fix that though. And then all you have to do is go to your firewall rules and go to your LAN and policy-based route. In this case, I'm coming in on WireGuard, so I'm going to policy-based route anything leaving WireGuard, my remote access WireGuard. I'm going to send that out the Mullvad gateway, and then Mullvad, I'm just allowing everything. So I'm policy-based routing IPv4 out to Mullvad, and this allows me to just kind of test that. And it works. And everything is good there. I know this video is already approaching 30 minutes. There's been a lot that has changed, so I feel like I need to talk about some of these things. The last thing is services. In the old versions, we were bringing up the WireGuard interfaces kind of organically when the package was started, and this was throwing services for a loop. I know that in a previous video, I discussed the logic of renaming our interfaces from WG to ton_WG. And that prevented, configurations from breaking firewalls if you were to restore them without the package. Because pfSense ignores interfaces that start with TUN. It will not cause an interface mismatch if it doesn't have those interfaces configured at boot. But what this does mean is it means that services like dpinger, FRR, Unbound, all of these services that are relying on these interfaces being up when those services are started, those services have to be bounced. So if you're using an old version and you reboot and you notice that your gateways are pending, that's because dpinger needs to be restarted. So we're actually going to go back. We're going to kind of find a middle ground, and we're going to go back to using an early shell command. And that early shell command is going to ensure that the WireGuard tunnels are started first. So I'm going to go ahead and demo that here. So let me go back to this and hit exit. And we're going to go ahead and restart this box. And we're going to look at the boot up process, just so you can see how that works. So we'll let this start. We're stopping the WireGuard package, and we're going to go through a normal reboot. So I'm not going to speed this up. I'll just talk to make things a little less boring for you. So we're going to look for, it's going to happen really quick, but this is actually the same time when Netgate was starting WireGuard tunnels. Right here, you're going to see starting, right there, configuring WireGuard tunnels done. So our WireGuard tunnels are already up way before the services start. So, Unbound is starting, and FRR and other things are going to start later on as well, but now our tunnels are up before these services are started. So this is, really a simple thing, and it works. So this early shell command is not going to be left on your box when you uninstall the package. The early shell command is removed. When you install it, it's installed. But that's going to ensure that services don't need to be, restarted after WireGuard is started. It sort of doesn't really make sense to do that anyway, because during the boot up process, all the services just started, and after WireGuard starts, now we have to restart. Maybe not all the services, but all the services that depend on WireGuard. So that could be free range routing. It could be, obviously dpinger if you have assigned interfaces and you're using gateways. Unbound if you're, using DNS. So we're just not going to worry about that. We're going to use the early shell command to get those going if the package is installed. If it's not, then the package will be, reinstalled. And then at that point, we'll consider, restarting, services. But at startup, we're going to use that early shell command to ensure that our tunnels are created before other services are started that might depend on those interfaces. So that's pretty much all that I have. It's a pretty big change, but let me tell you, the stability, the snappiness of the package, it really feels like a first-class citizen in pfSense. And you can see here, I just restarted, and both my Mullvad V4 and V6 gateways are online. So it's working better than it has ever worked. I'm really proud of where things are going, and I look forward to continuing on in this journey with you guys together. So again, if you're interested in following along on GitHub and also GitHub sponsors, this does take time out of my day, waking up very early, 4:35 in the morning to get some work done before my day job starts. Please, I encourage you to check that out and help support this project in the long haul. Netgate, as you have probably already seen, if you're new, Netgate is endorsing this project. They posted a blog post about it yesterday. So this is the future of WireGuard with pfSense, and I encourage you to join in on the project, supporting whether that be bug fixes or code PRs, or even monetarily through one-time sponsorships, or even better yet, monthly sponsorships. So with that being said, I'm going to leave you with that. And if you have questions, feel free to leave comments in the comment section. Hit the thumbs up to like the video, share it, and we'll see you in the next video. So thanks for watching.